What if we told you there's a tiny fish that can lift heavy objects as large as a house? You might think we're talking about a blue whale, which is the largest creature to have ever lived on our planet. But no, we mean a small fish that's less than 2 inches long. This amazing species can lift items that weigh up to 300 times as much as it does. And it does this using a suction cup. How is this even possible? Keep watching and you will see how this fish uses its natural abilities to get out of dangerous situations and hunt prey. Meet the clingfish. Clingfish can be found along the Pacific coast of North America. They live in the area between the low tide mark and the high tide mark, so they're constantly exposed to air and the sun. Clingfish need to find somewhere safe to hide or they'll dry out and die. And although they're small, measuring just under 2 inches long, these fish are quite heavy for their size, thanks to their bulky heads and powerful jaws. Clingfish tend to weigh around 2 pounds, which means they can lift objects weighing over 300 times their body weight. So what's the secret behind their incredible strength? To survive in such harsh conditions, clingfish evolved a special organ that allows them to cling to life. It's an adhesive organ located on their underside that acts like a giant suction disc. The disc is formed from their pectoral fins and surrounding skeleton, bordered by a series of hexagons. These shapes may look flat when observed by the naked eye, but when scientists examined them under an electron microscope, they saw something incredible. Each hexagon is covered with tiny hair-like filaments. These microscopic structures are similar to those found on the feet of beetles and spiders. They create millions of tiny hooks which dig into whatever surface they're clinging to, keeping the fish secure. Even better, these suction cups work underwater and in the air. But how do they compare to man-made suction devices? In nature, not even the strongest glue can match the versatility of a clingfish. Thanks to their flexible filaments, they can stick to most surfaces, including rough ones, with the exception of completely smooth and slick surfaces. When it comes to holding power, nothing beats clingfish. They can stick to surfaces underwater and in the air at different angles and remain attached even when the water temperature rises. On average, they hold on 4 times more securely than commercial suction cups. According to Oddity Central, this feature also helps clingfish hunt down and eat their favorite meal, limpets. Limpets are marine mollusks that cling tightly to rocks. They're slow-moving creatures that spend most of their time sucking down plankton. Because they move so slowly, limpets make easy prey for clingfish. And yet removing them from rocks can be challenging. If you try to pry off a limpet yourself, you'll know how difficult it is. Their undersides are perfectly round, making them incredibly hard to pull away. But clingfish don't have this problem. With their strong grip, they can easily detach limpets from the rocks they cling to and devour them whole. Suction cups are used by a variety of animals, including starfish and octopus. However, none of them come close to the impressive grip of a clingfish. What's even more surprising is that clingfish can regulate how much suction they apply. When they're resting, they reduce their grip so they won't accidentally dislodge themselves from the rock. But when they spot a tasty meal, they use their tails to increase the pressure inside their bodies. This causes their filaments to bend, creating a strong vacuum that sucks them onto the rock and allows them to dislodge limpets. Clingfish can exert up to 15 newtons of force with their suction cups, which is enough to lift weights of up to 300 kilograms. For comparison, the heaviest weight any human has ever lifted is 511 kilograms. That's nearly 34 clingfish. Now imagine lifting almost double your body weight. This would be equivalent to a 150-pound person picking up a Volkswagen Beetle. And although clingfish are only 2 inches long, they're extremely strong. They can carry objects weighing up to 360 times their own weight. And clingfish are much lighter than beetles, which weigh around 40 pounds. So the next time you see a tiny fish, don't be fooled by its size. A single clingfish is capable of lifting a full-grown man, assuming it can get a good grip on his clothes or hair. Clingfish have been studied by scientists who are amazed by their natural abilities. They want to understand how clingfish can support such high loads and remain stable. By learning how to enhance grip strength, scientists could develop new technologies that will make it easier to transport goods and equipment. In addition, studying these suction discs could help us create better medical equipment. For example, minimally invasive surgical techniques require instruments that can adhere to internal organs without damaging them. If scientists can figure out how to strengthen the grip of miniature suction devices, they could improve the safety of certain medical procedures. Even NASA is interested in the technology behind the Clingfish. They want to learn how to create an adhesive material that can withstand the stress of space travel. Because Clingfish can survive sudden changes in water pressure, they may hold the key to developing new materials that can withstand the extreme conditions of space. Currently, NASA uses reusable adhesive strips that aren't very durable and lose their sticky properties after multiple uses. But Clingfish offer a potential solution. If scientists can understand how the microscopic hairs on their suction cups interact with different surfaces, they may be able to create new adhesives that will stay strong and reliable for longer. So far, engineers have developed miniature suction cups that are inspired by the structure of a clingfish. But before they can use them in space, they need to conduct further tests. One challenge is ensuring that these suction cups will work properly in microgravity. Another issue is that they need to be sterilized before use. And it's unclear whether the sterilization process will damage the suction cups or change their properties. However, scientists are optimistic that the benefits of using clingfish-inspired suction cups will outweigh the challenges. They could revolutionize industries ranging from construction to healthcare. In fact, scientists have already created a prototype of a robotic fish that mimics the clingfish. It has a built-in battery that provides 48 hours of power and can swim at a depth of up to 200 meters. It moves in the same way as a real clingfish and can even mimic their behavior. One day, scientists plan to program the robotic fish to perform tasks underwater, such as cleaning oil spills. But first, they need to obtain funding for further research. Creating a robotic fish that can explore the ocean floor is an ambitious project. Although it's currently limited to a depth of 200 meters, scientists hope that one day it will be able to reach even greater depths. The potential applications of this technology are endless. Robotic fish could help humans explore parts of the ocean that have never been seen before and discover new species of marine life. Now let's take a closer look at the clingfish. As mentioned earlier, this small fish is just under 2 inches long. Despite its size, it's heavier than other fish of the same size. Its weight ranges from 1 to 2 pounds, which means it can lift objects that weigh up to 300 times their body weight. When fully grown, clingfish are usually 1.75 inches long and weigh 1.4 ounces. They typically have a lifespan of 11 years and grow at a rate of 1 inch per year. Interestingly, the oldest clingfish ever recorded lived to be 17 years old. Clingfish can be found in the eastern Pacific Ocean, from Vancouver Island, Canada, to San Diego, California. Although they prefer rocky bottoms, they can also inhabit sandy areas. However, they must have access to crevices or holes where they can hide during low tide. Clingfish have been observed at depths ranging from 2 to 460 feet. These fish are primarily carnivorous, feeding on mussels, clams, snails, and other invertebrates. They also consume small fish, such as anchovies and sardines. Their preferred habitat is the lower intertidal zone, where they face constant challenges due to changing water levels. During low tide, they must contend with predators such as shorebirds and seals. To avoid drying out, they retreat to protected crevices or bury themselves in mud. Meanwhile, during high tide, they must deal with the force of incoming waves that can dislodge them from rocks. Despite these challenges, clingfish have adapted to thrive in such conditions. They play an important role in their ecosystem by controlling the populations of limpets and other invertebrates. In turn, they serve as prey for larger marine animals such as sea otters and fish. Clingfish have several predators, including crabs, sea stars, and fish. Some birds also prey on clingfish, but this doesn't affect their overall population. However, the presence of predators keeps their numbers in check. In conclusion, the clingfish is truly an extraordinary creature. Its ability to lift objects that weigh up to 300 times its own weight is truly remarkable. By studying this amazing fish, scientists hope to develop new technologies that will benefit various industries, from healthcare to space exploration. The clingfish may be small in size, but it's big on potential.